My name is Joshua McKenty, and I'm the field CTO for Cloud Foundry at Pivotal. I always start with this quote because a long time ago I was the technical lead of the Netscape browser. And early in my career, the idea of continuous deployment or continuous delivery was still very new. This was one of the first times I had seen someone write it down as a mission statement. Bob Parsley was the product manager for the browser, and he had this sign on his office door. And his focus was always to get software into the hands of the users as fast as possible. I like to tell the Netscape story because when we released the Netscape 8 browser, we released the first update to that browser 24 hours later. And that wasn't a plan, but our ability to do that made a huge difference to the success of that product. So I'd like to put this into context for the rest of what you've heard of today. And I want to talk about this idea of a cloud-native pipeline, moving software from idea into production as fast as possible. And I think it's worth starting out with the idea that doing the same thing and expecting a different result is a definition of insanity. And in times of change, the most important skill is to be able to learn a new way of doing things. So I know most of the speakers today have talked about this idea of software as changing whole industries and the effect that that is having on those industries. These are obviously some examples that have been used earlier today, but I wanted to come back to them just to put it in very stark contrast. For each of these companies that have entered the S&P 500 in the last few years, and for each of these companies that have exited the S&P 500 in the last few years, there's really only one difference. The difference is how fast they can move. The difference is how quickly can they get new ideas into the hands of their customers. So I think we've used a lot of terms today. I'm going to use a bunch more terms. Folks talk about Agile. And the idea behind Agile came from Toyota, came from Japan in the 1920s. But it was written down not so long ago in what's called the Agile Manifesto. This is the first principle in the Agile Manifesto, and it says, our highest priority is to satisfy the customer through early and continuous delivery of valuable software. So the definition of Agile actually starts with continuous delivery. And when we came up with Agile, first in the 1920s at Toyota with lean manufacturing, since then in software, and now in operations, this goal of continuous delivery has always been the goal. But it really wasn't until we had cloud-native platforms that we were able to achieve that goal. So we're talking about this goal of continuous delivery. The term that Toyota used for this was jidoka, right? Which means automation with a human touch. And this kind of automation can't be used on legacy applications. It doesn't work. You can't take an application written in COBOL that's running on a mainframe and deploy that to the mainframe hundreds of times a day. So you have to embrace a new kind of application. So we call that 12-factor. And there are 12 factors in 12-factor, but they're hard to go through the whole list, so I wanted to summarize a little bit. The summary is this. We are used to building our configuration and our code into the same repository. We mix our constants and our variables. We have to separate those. We're used to thinking about our data and our processes as being part of the same application. We have to separate those. We have to separate our horizontally scalable, stateless processes from our durable, stateful data services. And we have to separate the process of building application artifacts from the process of deploying and running them. When we make those separations, we end up with an application that can be cloud native. Now, to achieve the benefits of continuous delivery, we have to trust the platform that we use to operate it. That trust means things like log management are not written into the application. They're a feature of the platform. That the decision, the connections between the processes and the data services are managed by the platform. And that the scale of those applications, whether they're running a single process in a single container or 1,000 processes across 1,000 containers, that orchestration is managed by the platform. And I'm going to talk more about how we achieve that as we go. Now, I often talk to very large organizations around the world who say, hey, we want to change. Tell us what tool to use. Tools can help, but tools are not change. Change is about culture. And the important part of culture is what you do every day. It's not a statement, it's not a mission statement that you put on the wall. Culture is not something you change. You change how you do your work, and a culture emerges from that change. So there's a culture that Danny and Rob have talked about that I want to summarize as part of this, because achieving continuous delivery is about changing the kind of applications you build, the way you operate them, and the culture of the teams involved. Now, this idea, collecting all of these pieces up, and you might have heard the term DevOps. This is one of those cultural aspects. Have the developers and the operations teams talk to each other. Have them share responsibilities. This idea of continuous delivery, the idea of using containers, of breaking up large applications into lots of small pieces in microservices. All of these ideas together are now being called cloud native. So when you hear this term, what they're talking about under the hood is these concepts brought together. And they have a lot more value when combined than they do individually. They have a much better probability of success when they're used together. DevOps is about culture. Continuous delivery is a process. Containers are a technology, and microservices are an architecture. But there's something missing in this picture. It's a CloudNative platform. It's interesting that we look to the Silicon Valley software startups to talk about cloud native. We think of Amazon, of Netflix, of Google, of Yahoo, and we say, how was it that they were able to pioneer continuous delivery? And just to emphasize that for a moment, Netflix deploys code into production thousands of times every day. Pivotal now has customers using Spring Cloud to deploy into production hundreds of times every day. Etsy deploys hundreds of times a day. It's no longer just the Silicon Valley startups who are embracing continuous delivery. But to the best of my knowledge, no company has ever achieved continuous delivery without a cloud-native platform. They've either built one of their own, or they've used Cloud Foundry. We talked about DevOps. There's shared responsibility, there's common tools, there's common language. There's this idea that in code, we'll separate the build steps from the deployment steps from the running steps. But in our teams, we share that responsibility. If the code is broken, there's no way the operations team can make it run. If the code wasn't built to be measured and monitored, there's no way that can be added on effectively afterwards. If it wasn't designed to be horizontally scalable, there's no way the operations team can do that efficiently. If it wasn't designed to be run in multiple different environments so that it could be tested appropriately, you've created a huge burden of work for operations. So bringing those two teams together, I mean, the easiest way to bring them together is literally to move their desks. People ask me, how are we going to make these cultural changes? I say, well, change where people sit. Move a chair. It's a radical concept, but it actually really works. Yelp, I think it was Yelp, pioneered the idea that everyone's chairs were on wheels. They would just roll their chair over to where they could sit next to the person they were going to work with. Continuous delivery is a concept and it's a goal, but there are also a set of tools and a set of processes that support that. And we talk about that as being a cloud-native pipeline. We're going to come back to this idea. Microservices. It's a great concept. People are really excited about it. Make sure you're doing it for the right reasons. Microservices are a solution to scaling Agile. If your team has gotten too big to work on a single code base without slowing each other down, microservices are a solution to that problem. They're not a solution to a technical problem, they're a solution to a cultural problem. So if you are a very small startup, if you have 4 or 5 people, microservices could be a waste of time. But for very large organizations, especially with large, complex systems, that's where this architecture delivers the most value. All right, let's talk about the cloud-native platform. And I started out by saying that this talk would be about change and about thinking about new ways of doing things to solve a new generation of problems. We've had tools for, let's call it DevOps, for a while. We've had configuration management for a long time. Many of you have probably used Chef or Puppet or Ansible or maybe Salt, perhaps CF Engine. They're very powerful tools. But the architecture they were built on is now 10 years old. Everything that has happened in the last 10 years includes cloud, mobile, social, and big data. Amazon was launched in 2007. The Apple App Store was 2007, 2008. The Google Big Table paper and the creation of Hadoop was around the same time. Facebook is less than 10 years old. So 10 years ago, when we invented Puppet, we were solving the problem of getting one process running on one server. That's not the problem we have anymore. We have a distributed systems problem. Every application that the modern enterprise writes is a distributed systems application, just because of problems of scale. So solving a distributed systems application problem takes more than configuration management. It takes artificial intelligence. The component inside Cloud Foundry that makes it amazing is what's called narrow AI. Okay? From a mathematical basis, you could call this a constraint solver. And I'm going to continue to talk about the power of constraints. So the difference is when you have a script, you run a script and it produces a result. And then nothing happens until the next time you run that script. That's not how Cloud Foundry works. Cloud Foundry is always running. So you say, hey, I want to make sure that my application has 100 containers running for it. Cloud Foundry will start those containers, and then it will watch them. And if one of them dies, it will start a replacement. If the network goes down, it'll launch new containers in a different availability zone. If your application crashes, even though the container hasn't died, it'll restart it. Every layer of Cloud Foundry is designed to be resilient in that fashion. It's not scripting. Scripting can't solve cloud-native application problems. It cannot deal with distributed systems. And it's really important to note that virtual machines have not gone away. Containers are not that new. They're 20 years old, but they're recently popular, and they're very powerful, but they're not enough. Let's talk for a moment about Cloud Foundry. I'm sure most of you are familiar with it by now, but I just want to give a very brief recap. It is the world's leading open source cloud-native platform. It's supported by dozens of major organizations. In Berlin a few weeks ago at the Cloud Foundry Summit, we announced that there were now 50 members of the Cloud Foundry Foundation. It can run multiple programming languages. So whether you're writing applications in Java, or Ruby on Rails, or Go, or .NET, you can run those applications using Cloud Foundry. It uses both virtual machines and containers. And it deals with both the stateless applications and the stateful data services. You know, containers are great. I like containers. In a previous life, I was the co-founder of OpenStack. So I've been working on cloud for a long time. And the founder of Docker is a friend of mine. So I've worked with Docker containers and Garden containers and Warden containers and LXC and all of these various container technologies. They're very powerful. They're designed to start very fast. They're designed to be disposable. They're not a great place to keep your database. You don't want your database to be disposable. All right. I've talked about the cloud-native pipeline. I've hinted at it. We're going to finish with that, but let me cover one more thing on the way there. Cloud Foundry was built to run on elastic infrastructure. Infrastructure as a service. It's incredibly portable. It can be run on OpenStack, on vSphere, on Amazon, on Azure. There are community members running it on Google Compute. It's been made to work almost everywhere, including bare metal technologies like RackHD. But it has to be elastic infrastructure. It has to be an IaaS that provides an API. That's a contract. and that IaaS has to provide durable storage, networks, and compute resources. Inside Cloud Foundry, we use this component called BOSH to drive against that elastic infrastructure. And as I hinted before, BOSH is not scripting. It is a narrow AI system. It makes it possible at Pivotal, as an example, we provide Pivotal Web Services, which is a hosted Cloud Foundry system used by developers all over the world. It has tens of thousands of applications on it. And we manage all of Pivotal Web Services with 4 people. So when you think about scaling operations teams, say, well, how many people will it take to run all of these applications? Well, 4. We need 4 people because we always do things in pairs. And we need to make sure that somebody's awake all the time just in case there's a disaster. So we have a pair in China and a pair in San Francisco. There's one other piece that I need to hint at here, which is, I mentioned microservices, and I'm going to come back to this in a second. Microservices are a very powerful solution. They create a new class of problems. When you break an application up into 10 different pieces, those pieces now have to talk to each other. Your service discovery becomes a challenge. Load balancing needs to be configured differently. Monitoring now needs to work differently. So there are new challenges there, and I'm going to get to that in a second. But it's worth understanding that a cloud-native framework has to deal with VMs, has to deal with containers, it has to deal with the services above. These are all necessary components to deliver continuous delivery. All right. I've been talking a lot about going fast, and I mentioned earlier that Etsy goes fast, Netflix goes fast, Amazon goes fast. Large enterprises want to be able to go fast. So measuring how slow they are today is really helpful. When Intel started with Cloud Foundry, they knew that going from idea to production took them originally 18 months. And then they deployed OpenStack, and they got it down to 6 months. 3 times faster. It's pretty good. They put Cloud Foundry on top of OpenStack, and they got that down to a week. So they can have an idea on Monday and have running software on Friday. Allstate can now do that in 3 days. Andy would like to say it's minutes. The deployment is actually minutes. But to have from an idea to running software, they've done now in 3 days. So that's important. That is the goal of continuous delivery. It might not be, 700, 800, 900 times a day, but 3 days is fast enough to keep up. It's fast enough to deal with Google becoming an insurance company. I want to flesh out this picture a little bit more. When we talk about a cloud-native pipeline, we are literally talking about every tool and process that it takes to go from an idea to a running production system over and over and over again, not just once. Deploying software to production once is boring. I could do that right now from stage. I could, log into Amazon, create a server, and make Hello World run. But in order to make it Hello World version 2, I'd probably have to turn it off. And if I had 1 million people using it and I turned it off, it wouldn't be good for business. So the goal of a cloud-native pipeline is 0 downtime. Always keep the application running even when you're deploying 900 times a day. You need source control. You need continuous integration tools. You need build systems. You need API-driven environments, API-driven infrastructure, and you need a cloud-native framework that makes it easy for your developers to deal with all of this underlying complexity. All of these services can be run by Cloud Foundry. You can host GitLab and Artifactory and Jenkins or Concourse on top of Cloud Foundry. You can build your entire pipeline in the same environment that you run your applications. Now, so I wanted to talk about microservices for a second. It's not simple. It sounds exciting to say, hey, we could have all of these teams building different services and they don't have to wait for each other anymore. They can have autonomy. But all of a sudden you say, well, here's a team that built a user microservice. And we've realized we need to change the database to hold phone numbers. This other team is using that service already. This third team is waiting for the new version. What do? All of a sudden, we're back to the old monolith problem of each team waiting for the other team, waiting for the other team, and all of a sudden, we're waiting for months. There's a secret. Run 2 versions at once in production. It's called N+1. It is the only way to make microservices work. But then it adds new problems. How do you keep track of which one you're supposed to connect to? There's user service version 1 and user service version 2 and user service version 2.1. So the first company to deal with this problem was Netflix. Really, to deal with it in a serious way. And they used a pivotal product called Spring. Spring Java framework. It's the most popular Java framework in the world. And they built a set of open source tools to solve modern microservices problems. The Spring community said, well, this is great. It's open source. It's built with Spring. Everybody wants it. Let's make it easy to use. So they took those open source components and they turned them into Cloud Foundry services. So that's Spring Cloud. Now, when you build a microservice, you register it into the service registry. And then other components, other microservices that need to use that, know how to find it. They just make a call to the service registry and they get all the connection strings they need, whether there's one instance of that service or 1,000 instances of the service. Circuit Breaker deals with this problem of what happens when your service isn't running. Do you want the whole website to crash? Your whole mobile application to go off? No. If you have, let's say, 700 different microservices, as Springer does in Springer Link running on Cloud Foundry, you need any one of those to fail and the rest of the application to keep working. That's a circuit breaker pattern. So that's supported using Hystrix. And that's a Spring Cloud service. Now, if you're building on your desktop or your laptop and you want to get started as quickly as possible, you're probably going to use Spring Boot. Spring Boot has become so popular, it is now being downloaded almost 2 million times a month. And it makes it really, really easy to get started building cloud-native applications. And then when you need to run those applications at scale, you need to connect to other microservices, you can step into Spring Cloud and start using these other tools. I said before that culture is not something you change, right? Culture doesn't change because we want to change it. Culture changes when we have transformed our organization. The the precursor to Agile was Lean, as I mentioned before. And Lean manufacturing, Kanban approach developed in Japan, the Kanban masters used to say the way we create pull is by going into the factory with a crowbar and moving the machines. This idea of moving the machines is exactly what you're doing when you think about a pipeline as being the way that software goes into production. It's pull. It's not about a schedule. It's about each component telling the other components what's required, starting from the customer demand. But if you want to change your culture, it has to start from inside your organization. It has to have your voice. JPMorgan Chase, we've been talking about a lot today. They've been doing a lot of work to transform their own culture to a cloud-native model. And this is their cloud-native maturity model. Alan Beck, who works at JPMorgan Chase, was in Berlin a few weeks ago. And he shared this with me. This is what they're using internally. You can't skip to the end to cloud native. It's too big a leap. But there is a bridge that you can build for your development teams, for your operations teams, for your product managers, for your senior leadership to understand why continuous delivery is important and how these tools and processes can get you there. There are a lot of details here. The details are not really what matters. What matters is understanding that it's possible. The pivotal way is always to learn by doing. Pair program. Paired operations. Danny talked about this earlier. Always pair. And that approach is so powerful, we never do anything without pairs. The other one that's important to remember is test-driven development. And I don't know if this gets emphasized enough. I don't think it does. The spirit of continuous integration, the spirit of continuous delivery, is that your tests are always being run. You know, it was a Toyota expression that went along with Jidoka that said, always stop production so that production never has to stop. Which is very Zen. But that is the spirit behind continuous integration. Always run the tests. Always fail if any test fails, so that you can always trust that production is running things that work. And there's a pattern to get there from your existing applications. If your applications have no tests today, you don't have to stop and spend 100 years writing tests before you can start thinking about continuous delivery. All right. I wanted to close with a Sengyu, and I didn't write this. Ansi Fakori at Pivotal wrote this. But I think it sums up the idea of the cloud-native platform. Here is my source code. Run it in the cloud for me. I do not care how. Arigatou gozaimasu.